Hello dear students. So the third type of atomic radius that can be expressed, it is expressed in the form of van der Waals radius. Now we have seen in the periodic table that group 17 elements, for example in this figure it's given group 17 elements, they have smallest atomic radii. Reason being that nuclear charge is maximum. Now when we move from group 17 to group 18, this is 18 group, it is seen that suddenly the atomic radii that tends to increase. So noble gases, they are bigger in size. For noble gases, the reason is that outermost shell or the valence shell electrons are completely filled now. The outermost shell is completely filled. Hence the electrons, there is inter-electronic repulsion. They are closely arranged and there are inter-electronic repulsions, and due to inter-electronic repulsions they tends to repel each other, and hence nuclear charge decreases, or we can say that radii increases. In order to explain the radius of noble gases, we use the term van der Waals radius. What is van der Waals radius? It is half of the distance between the nuclei of two non-bonded neighboring atoms of two adjacent molecules in solid state. For example, in this figure it's given two molecules are there. These are bonded by covalent bond. This is one molecule and this one is another molecule. They are bonded by normal covalent bond, and this radius we call it as covalent radius, this much distance, right? Now when we take these two adjacent molecules into consideration in solid state, so the distance from the nucleus of one atom of the molecule to the another atom, non-bonded atom of the another molecule, right? This distance is called as van der Waals diameter, and half the distance of these two, that is called as van der Waals radii. As you can see in this picture, two atoms, these two non-bonded atoms, this one and this one are shown, these two non-bonded atoms are shown, and the total distance between from the nuclei of one to the another one is called as van der Waals diameter, and half the distance is called as van der Waals radius. So what is van der Waals radius? Van der Waals radius is van der Waals diameter divided by 2. Now one more thing you have to note. Now we have discussed about three types of atomic radii. One is covalent radius, metallic radius, and van der Waals radius. Out of these three forms, van der Waals radius has maximum value, or the radius will have largest value because of the weakest forces, because the force of attraction is weakest. Two non-bonding atoms of adjacent molecules are taken into consideration in their solid state, so this distance will have largest value, whereas after this it's metallic radius, which is bigger in size, and the last one is covalent radius. So we can conclude that stronger the interactive force, the weaker is the, smaller is the atomic radius, right? So van der Waals radius will have maximum value, then metallic, and then covalent with least value. The next topic is ionic radius. In case of ions, whatever is the distance, that will be called as ionic radius for ions. There are two types of ions. One, cations, which are formed by loss of electrons, and when there is gain of electrons, so this leads to the formation of anion. So cation and anion, and their radius will be called as ionic radius. So the ionic radius can be estimated by measuring the distance between the cations and anions in ionic crystal. We have discussed the term covalent radius, so that was related to covalent molecules. We discussed about the metallic radius, that was related to metals, and in case of gases or isolated gaseous atoms, we discussed the term, or in molecules we use the term van der Waals radius. Okay, so ionic radius will be between the cations and anions in case of ionic crystal. Now it has been observed that cation which is formed by loss of electron is always smaller than its parent atom because of presence of less electron, because the cation is formed always by loss of electron. So the size of the cation or radii of the cation or ionic radius of cation is always smaller. Okay. In this case, two structures are given. One is for sodium atom. Sodium in its ground state, its atomic radius is 186 picometer. It has 2, 8 and 1 electron. So in total 11 electrons are there. 11 electrons are there and 11 protons will be there. So they will balance each other, and whatever is the attractive force, as a result the size of the shell that comes out to be in the range or atomic radius is 186 picometer. Now what's the change? When there is loss of this valence shell electron, it is taken out by providing heat or by any source. So what happens? That electron is lost now. Now how many electrons will be there in sodium ion? There will be 10 electrons. And what about protons? So they will be 11 in number. So what's the change? So 11 protons, they will attract these 10 electrons with greater force now. Or we can say that the number of electron decreases but the nuclear charge that remains same. Hence the force experienced by these 10 electrons from the nucleus that increases. Or we can say that effective nuclear charge per electron that tends to increase. And if effective nuclear charge increases, so naturally the radii tends to decrease. So the ionic radius of sodium ion is 95 picometer. So can we conclude this, that a cation will always have smaller radii than that of its parent atom. Now for anions, the size of anion will be larger than that of its parent atom. It is just opposite to that of cation. Cation has smaller size than its parent atom, whereas anion will have larger size than its parent atom. Now we have to relate that why this happens, because after addition, now let us take into consideration this figure. This is fluorine atom, this figure, and fluorine has 9 electrons, 2 in the inner shell and 7 in the outer shell. So 9 electrons are there. So now its outer shell requires only 1 electron to get completely filled. 2 plus 8. Now this is parent atom of fluorine, and when it acquires that 1 electron, so that electron has to enter in this shell. Okay. So when electron enters, so there are now 2 and 8 electrons. Right. So the outer shell contains 8 electrons, but the size expands. Reason being that due to entry of electron, there are inter-electronic repulsion, as you can see in this figure, this one. The arrows shows that these electrons which are present now, they tends to repel each other. And when repulsion takes place, the nuclear charge tends to decrease. The effective nuclear charge decreases. And due to decrease in effective nuclear charge, this leads to increased radii. So anionic radii that tends to increase. So we can say that fluorine atom has smaller radii, whereas fluoride ion has larger or bigger radii. Okay. Hence it can be concluded that size of anion is larger than that of its parent atom, and the reason is due to inter-electronic repulsions. Okay. Now towards the end, the isoelectronic species. Again, this is important. Iso means same, electronic means number of electrons. So just as we have discussed about cation and anions or ionic radii, So in case of cations and anions, after loss of electron or gain of electrons, their number of electrons becomes same. Such species are called as isoelectronic species. Okay. So the species which contain same number of electrons, they will be called as isoelectronic. But do remember, same number of electrons, but their protons tends to vary. So they will have different nuclear charge. Isoelectronic species are those which contain same number of electrons but have different magnitude of their nuclear charge. For example, in this table, it's given 10 electrons are there, number of protons are 7, 8, 9, and then 11, 12, and 13. These are actually ions given. Species may contain neutral, for example, neon can also be added. But in case of anions and cations, so nitrogen has, in ground state, it has 7 electrons and 7 protons. But if it has taken 3 electrons, so number of electrons in nitrogen ion, that is 10, and this N3 negative, the ion is N3 negative, nitride ion we call it as. So it has 10 electrons and 7 protons, and its ionic radii is 171 picometer, biggest in size. Then for oxygen in ground state, it has 8 electrons, but now after gaining 2 electrons, so number of electrons comes out to be 10, protons are 8, so oxide ion. And oxide ion, its ionic radius is 145 pico. So on, fluoride is given, then sodium ion, magnesium ion, and aluminum. Now what's the difference? They have same number of electrons, but they have different protons. Okay. And due to this variation in electron to proton ratio, the size tends to vary. Okay. So isoelectronic species, although they have same number of electrons, but the size or radii will be different. Now what we can conclude from this, that anion, when anion is having maximum negative charge, so its size will be, or its radii will be maximum than that of another. For example, N3 negative, 3 negative means it has acquired 3 electrons, so that repulsive forces will be maximum between the electrons, and hence its radii will be maximum. Then after that, oxide, only 2 electrons, so it will be smaller than that of nitride ion. In the same manner for fluoride ion. And for cations, lesser the charge, because sodium has just lost 1 electron, so its ionic radii will be 98 picometer, whereas magnesium has lost 2, so nuclear charge goes on increasing, and hence size decreases. So we can conclude that if an ion is having maximum negative charge, its radii will be maximum ionic radii, and that of cation, if it carries maximum charge, so its radii will be least. Okay. So with this we conclude the first property, physical property, that is atomic radii along with ionic radii.